Again to Let's Talk Chemistry with Pastor Dan. We're looking at heat of fusion and vaporization today, but instead of just jumping right in it, let's go back and review what we covered before. So here's a quick specific heat problem. What I'd like you to do is work this through on your own. Calculate the mass of silver needed to cause a temperature change of 74.89 degrees Celsius. It requires 99.090 kilojoules of energy. You do need to know the specific heat of silver since it's not water this time. Specific heat of silver, the C of silver is 0.235 joules per gram degree Celsius. So pause this, give yourself a chance to work through it. See if you come up with the correct answer. All right, here we go. So we start with our equation, delta H is equal to mc delta T. So we have our enthalpy, which is the energy, enthalpy of the reaction, 9.090 kilojoules. Move it 3 places to the right. 9090 with a bar over it because that last zero is after a number. After decimal is showing exactness. Significant, we don't know the mass. Specific heat is 0.235 joules per gram degree Celsius. Temperature is 74.89 degrees Celsius. So we rearrange the equation to solve for M. So delta H is across, still across. That means C and delta T are going to go on the bottom. So we take 9,090 with a bar over it, joules, divide by 0.235 joules per gram degree Celsius. My joules are cross out and divide by 74.89 degrees Celsius. My degrees Celsius cross out. When we do that, we get an answer of 516.5 grams. Awesome. All right, so here is what we're looking at today. Two substances, heat of fusion, heat of vaporization, both substances dependent. What does that mean? That means these are intensive properties. They don't change how much we have. They're always the same value no matter what. All right, so let's take a look at the heat of fusion first. Heat of fusion is defined as the amount of energy needed to convert a solid to a liquid. And when you use delta H of F, if you use the Q value, it would be Q, small q sub F, where C of F times M, and C of F is the heat of fusion constant. It's 336 joules per gram. You'll notice there's no temperature change. Why is there no temperature change? We're going through a phase change. We're going from a solid to a liquid. So as we go through that phase change, all the energy that was causing the temperature to go up is now causing the molecule to break, to the substance to come apart, the molecule bonds get farther apart. So because of that, the temperature will remain constant through the phase change. So it starts at 0 for water, it ends at 0 for water. There's no temperature change all the way through it. Alrighty, so here's the problem. Find the amount of energy needed to completely melt 123.60 grams of ice. And our equation again, delta H of F is equal to CF times M. Delta H of F is what we're looking for. That's our unknown value. C of F, since it's ice, it's 336 joules per gram, and the mass is 123.60 grams. So we don't have to rearrange it. I already set up the solve for my unknown. So just plug my values in, 336 joules per gram times 123.60 grams. My grams cross out, left with joules. Sig figs, I have 1, 2, 3, 4, 5. That zero's after number, after decimal, showing exactness. It's significant. This is a constant, so it's definitely significant. Answer is 41,530 bar over joules. That's correct. Alrighty. Now let's try another one. Determine the mass of water needed to require 8.699 kilojoules to completely melt ice. So again, my equation, delta H is equal to CF times M. Delta H, C of F and M, 8.699 kilojoules. Don't like kilojoules because again, CF is 336 joules. So I'm going to have to convert that, which I'm going to do right here. I'm going to get 8,699 joules. My CF is 336 joules per gram. Of course, M is unknown, but 336 on the bottom. Joules cross out. 1 over gram. 4 sig figs, I get 25.89 grams. Now, other concept we're looking at is heat of vaporization. Heat of vaporization amount of energy to convert a liquid to a gas. And so the equation now is delta H sub V is C of V times M, and the C of V a lot bigger. Why is it so much larger? Because of the fact that we're now moving the atoms of the substance even farther apart. We went from a solid to a liquid. Now we're going liquid to a gas, so it's going to take even more energy. And again, you'll see no temperature in here because we're going through a phase change. As we go through a phase change, the temperature remains constant. Water boils at 100 and its steam at 100. Temperature doesn't change. All right. So identify the mass of water needed to convert water into steam. It requires 113.4 kilojoules. Equation delta H of V is equal to CV times M. So my delta H of V is 113.4 kilojoules per mole. I'm going to convert that to joules. So therefore 1,000 joules is 1 kilojoule. We're going to get 113,400 joules. CV is 2270 because again it's water, joules per gram. And then my mass is unknown. Again, we're solving for unknown. M, opposite, is still delta H of V. CV, going to go on the bottom. So 113,400 divided by 2270. I have 1, 2, 3, 4 sig figs, infinite sig figs, 4 sig figs. My answer, I get 49.96 grams. And there we go. All right, one last one. Why don't you try this one on your own? Take a few seconds. Again, these aren't that difficult. And we'll go through it at the end. What is the amount of energy needed to completely boil 29.2550 grams of water? Okay, so take a few seconds, work it through. Alrighty, here we go. Delta H equals CV times M. Delta H is unknown because it's the energy, the enthalpy. CV is 2270 because it's water. Mass is 29.250 grams. Plug them in, grams cross out. We get 66,408.95, but I only have 6 sig figs. So to 6 sig fig, that's going to come to 66,408.9 joules. And here's 2 problems. Why don't you take a few minutes and try to work out those? Determine the amount of energy needed to melt 81.976 grams of ice. And what is the heat of enthalpy constant if the enthalpy of the vaporization is 100.95 grams of substance in the substance is 104.47 kilojoules of energy. Okay, so try both of those, and we're going to go over the answer once. So pause the video one more time, one last time. Okay, here we go. So for the answer to the first one, we're going to get 27,544 joules. For the second, 1,034.9 joules per gram. That's it. Hopefully that wasn't too bad. Take care. Be good. God bless.